Good afternoon, everyone. My name is Michael Sinatra. I'm the director of the Center for Digital Humanities at the University of Montreal. And it's my great pleasure to welcome everyone with my colleagues from the University of Ottawa, Jada Watson and Connie Crompton, and our colleagues at the University of Guelph, Susan Brown and Kim Martin. We are co-sponsoring this series again after. We've already had two wonderful talks in the series with one more to come in 2 weeks. And it's my great pleasure today to welcome Renée Sieber from the McGill University at the McGill Library. And I'm going to invite Jen Riley to say a brief word of welcome from McGill.
Hi, welcome from McGill. We are really happy to have some UDM people here today. We're glad that our the digital humanities from UDM and McGill working together strong enough to survive a pandemic. So we're happy about that. And we're learning hybrid technology and do presentations today. So we're looking forward to hearing today.
Okay, so hi everybody. We have people running around like crazy. Hi to the person who's recording me. Presumably Jen is going to turn this into presenter mode, and Michael is going to people watch the people waiting to get in. To let people in. Well, it's getting closer to the right presentation mode. So thanks, Constance, for saying that it's lovely to see a semi-in-person event, and we're seeing right in front of us the challenges of a semi-in-person event. I'm going to talk about AI for the rest of us. The rest of us is quite broad. I tend to focus on civic participation and participation of marginalized people using technology or confronting technology. But it is equally important for librarians and archivists with whom I collaborate regularly. And no, Jen, what you want is the little icon in the lower right.
Yeah, we're trying to do this. That one?
No.
We had it working just a minute.
Yeah. So I'm going to be talking predominantly about AI as deep neural networks. Although a lot of what we do is actually machine learning, and I'll clarify that a little bit. But while they're still working on it, I'm going to tell you a little bit about who I am. I'm a professor of geography, and I'm also in a school of environment. I'm also in the digital humanities here at McGill, and also part of Michael's Center. Sorry about these pauses. I also am an affiliate professor of computer science. So I wear lots and lots of different hats. I love working at the shaky knife edge of a lot of these fields. I tend to characterize my research as working at the intersection of social theory and software architecture. So I do look quite a bit at challenges to participatory democracy, the tensions between technocratic approaches and participatory theories. But I'm also interested in straight up tech. So I have two projects, one of which is a digital humanities project that looks at the use of natural language processing, or NLP, and I also do some feature detection work. And I just have been writing lately about XAI, or explainable AI, and the challenges and opportunities that proposes to glass box the black box. So I'm really interested in questions about how much technology is needed and how much literacy is needed to run these systems, which is a particular challenge for people in the humanities. I'm interested in how, for example, librarians work with computer scientists and data scientists to solve problems. I'm interested in how marginalized people can use the technology themselves to challenge government structures and to gain raw political power. I have worked, my specialty is in the use of computerized mapping in GIS. We call it public participation GIS. You just check again to see, oh, great. This looks like it's close. Business, we're close. Although I have looked at the ability of the public to run climate models themselves and not just look at the output of climate models. And I have looked at computational ontologies with indigenous people, and I'm increasingly interested in artificial intelligence and machine learning. So I have at the bottom of the slide that you don't see yet, that a part of this could be a Reddit AMA or an Ask Me Anything. So if you have general questions about the adoption of certain kinds of AI or ML, machine learning, or artificial intelligence, feel free to ask me as well. So, these guys are working on it. So, artificial intelligence, even though it's designed to mimic human decision-making, is characterized as a black box that is out of the reach of, I'm guessing, most all of the people who are in the audience. Thanks, Maria. The challenge is that we don't have multiple monitors.
Yeah, we're almost there.
We're almost there? Okay, cool. So the challenge is that AI, especially deep learning, deep neural networks, is opaque. It is a black box. It is incredibly hard to use. The people who work, this is fabulous. The people who work on AI, particularly in computer science, and this is, you see this in digital humanities, they tend to work on model development, or they may work on feature engineering of data. What they do not tend to work on is web development and user interface design. So that's a huge challenge for anyone who's getting involved in these fields or trying to use these technologies, because you essentially have to, at minimum, know SQL,
You need the pieces of avocado.
be able to use software libraries, understand Python, for example, to implement them. Because there is no easy to use interface for these systems. So, okay, so you see that, okay, so Jen,
Yes.
if you just minimize the notes there,
Okay, yeah.
and you know how to minimize the notes,
We will see most of your slides and.
you will see the
Editing.
slides, and then we won't have to worry about anything else.
Good enough.
Okay, great, so go to.
Yeah, let me get out of this. And then we share this.
Yeah.
Oh, I'm gonna share, change what I'm sharing.
No, leave it, do not touch that.
Yeah, but the online people are not seeing.
Oh, the
it.
online people,
Yes,
sorry.
I need to go back in Zoom and reshare my screen. I can do that.
Okay. So, one of the challenges of talking about AI is that a lot of people obscure what it actually is. AI is a quite vast bucket into which you have things as diverse as logistic regression, Bayesian statistics, random forest, decision trees, and then the deep neural networks. So while people in the various research labs in, Mila here at McGill, in Vector Institute in Toronto, in Borealis in Alberta, talk about AI, they're actually talking about something that is quite complicated, even though the moment that you look at deployment is the moment they're talking about something simpler called machine learning.
We're making it worse. Go ahead.
Making it worse.
Sorry about that, Renee. It's just
And then to add to that, because when we talk about AI and ML, we're talking about deep neural networks, or the excitement is around deep neural networks, then the fear becomes, well, how is it going to automate decision making? So a lot of my research and interest is, for example, around the federal government's proclamations about automated decision making. You may or may not know that there's a Canadian directive on automated decision making that being adopted worldwide that basically says, fill out this AIA, this algorithmic impact assessment. And if you get high enough marks, then we will trust the AI that you use. So this isn't necessarily further glass boxing the AI. This isn't necessarily creating greater citizen participation in AI or non-expert participation. Yes, good, leave it there. And go to slide 4. Yes, 4. Up to 4. That one. Okay. Yay! And is there anyone in the waiting room still, Michael?
I'm keeping an eye on it.
Okay. Okay, great. Hi, everybody. So you get a sense of this huge basket or bucket of things that constitute AI. The proclamations are in the deep learning, the dark gray box. The actual implementation, what most people are doing, is in the gray box. And what people are most concerned about is the yellow box. So next slide. So as I alluded to, it is especially out of reach for the general public and marginalized communities who may be the most impacted by these automated decision systems. Next slide. When people talk about impacts of the general public, impacts to marginalized community, they predominantly think about FRT, facial recognition technology, and they think about predictive policing. Here is a map from Atlanta, Georgia, generated by a company called Predpol, it's since changed its name, that uses predictive algorithms to map hotspots for potential crime. Okay, you might think to yourself, it's great because we can create efficiencies about these technologies and better direct our taxpayer-funded police to target hotspots of crime. But the problem is that we know that historically police data is ridiculously biased. It's ridiculously biased geographically, by police targeting certain areas that are predominantly poor and minorities. We know that they don't focus on white-collar crime. So it is also targeted to specific types of crime. So this is also an example of the predominant type of deep neural networks or deep learning algorithms called classificatory systems or classification systems, in which you use training data, we use data to train your model. So what am I talking about here? When I talk about deep learning, I'm actually talking about a probabilistic mesh of neurons that get tuned and retuned over and over again till it predicts the results of your training data. So you have a training data that says, here are all these people who got arrested. Surprise, most of them are people of color. So you have known input and known output attached. So then you train iteratively until the model predicts according to the way that the system has been, according to that input data. So when you put in new input data that has unknown outputs or classifications, ooh, here's a picture of a scary black man. Is this scary black man a criminal? And I'm being hyperbolic here because this is the nature of the way these, of the output of these algorithms. It's driven by fear from the public. It's reinforced through these more efficient algorithmic approaches, and then produces in a more efficient way a replication or a reinforcement or a strengthening of the biases that we introduced into the system. So whether we're looking at natural language processing of social media data, or whether we're looking at predictive policing, the same kinds of classification or the use of algorithms to put things into buckets is what we mostly are concerned with when we talk about deep learning or deep neural networks. Next slide. So let me talk a little bit about the project that I've been doing for the past 2 years, funded by SSHRC, called AI for the Rest of Us. Next slide. So this is predominantly focused on the question of whether the public can be involved in government decision-making that is automated by AI. Part of that involvement might be being a part of the way that the algorithm is chosen and deployed. Part of that involvement might be building their own algorithms, for example, to contest the predictive policing models that a government might have instituted. Next slide. I just wanted to mention, since philosophy is a part of the humanities, that some of this research is also looking at the way that we deploy ethics when we talk about AI, when we talk about deep learning. One of the challenges when we decide which AI we should choose or which AI we should not choose is governed by what is called virtue ethics or codes of conduct. So as long as you are good in your heart, the AI will be good as a result. You can note the skepticism in my voice when I say that, because obviously what this does is it individuates responsibility and doesn't park responsibility in larger structures like the nature of police, for example. Yet this is the most often place where we situate ourselves in talking about ethical approaches. There are other approaches like utilitarian ethics or consequentialist ethics, which is the greatest good for the greatest number. Unfortunately, you will often see at that point arguments for protecting the children or protecting the state in a national security context, because wouldn't that be great? So there is a case in Scotland right now in which facial recognition technology is being used as a replacement payment system for school lunches. So why have people, especially in an era of COVID, why have people touch things when they could just show their face and their account is debited for that lunch? But and people will make the argument, well, that protects lots of people and that protects children, so why don't we do that? And of course, the problem is that we acculturate generations to accept surveillance. And that might be a bad thing. So up to deontological ethics, where we talk about right or wrong, we might say that irrespective of the number of people who might be helped, we won't do it. So at the United Nations, there is a huge debate, and also in the European Union, there's a huge debate, for example, about the use and development of autonomous weapons systems, systems that have AI embedded in them. And people are talking about, similar to facial recognition technology, that there should be bans on these things. And the United Nations unfortunately backed off on their original proposal to ban autonomous weapon systems, and instead leave it to, in some cases, a moratorium, a pause, and in worst cases, leaving it to self-regulation, back down to virtue ethics. Let's leave it to the Microsoft of the world, let's leave it to the various weapon manufacturers to say that they will do good and they will not deploy them in theaters of war. So obviously it's far easier to do virtue ethics, it's far harder to do deontological ethics, but it is an important thing to consider beyond the mere, is this a useful tool for me to do text mining or optical character recognition? Thank you. So one of the things that's one of the things we've been doing in AI for the rest of us. Another thing that we've been doing is looking at forms of regulation. In Canada, the algorithmic impact assessment is the most popular form. Unfortunately, there are often carve-outs when you look at this. So for example, national security is carved out, Canada Revenue Agency is carved out, so CSIS, Canada Revenue Agency, a lot of them say, look, we can't be subject to an AIA because that might expose confidential information, whether it does or not, and impacts our own ability to be efficient and to catch the bad guy. So we're trying to look at redesigns of these AIAs to try to bring in greater public consultation and greater and meaningful public participation, because of course that is one of the huge challenges is public consultation, as we are well aware in Quebec, is often check the box or let people rant. It is not about influence in public policy and actual change to public policy. So how do we move past these kind of process-based, well, we invited a lot of people, we got thousands of people to comment, so check that off, we were good, to more epistemic, more existential questions about who gets to define what's meaningful and what's not meaningful. And can we ever define self-regulatory systems, of which this is? So an individual firm or an individual agency says, okay, this is the challenges in possibly deploying something to determine visas, entry visas for people coming into Canada, and look at whether or not having an AIA that is done by Immigration and Refugee and Citizenship in Canada will ever ensure adequate participation from people whose relatives have been languishing in Afghanistan or wherever to come into the country, or Ukraine, for example. Next slide. So a lot of our work has been on a ladder of citizen participation. This builds off probably the most famous article in urban planning by Sherry Arnstein in 1969 called a ladder of citizen participation. It is durable, even though it's been modified over time. And in the next slide shows what this ladder of citizen participation looks like. And you can see that for Sherry Arnstein, who at the time was looking at public participation vis-a-vis public housing, in other words, the residents of the public housing talking about the conditions of the public housing, that many of the tactics that are used for citizen consultation, public involvement, etc., there are many words to describe this, involvement, engagement, participation, public, marginalized groups, so that even the people, sort of stakeholders, there's disagreements about how expansive or restrictive those terms are. But you'll notice that many of the tactics used by government or even the private sector are actually not participatory at all. And she calls them non-participation. So a lot of things that we see going on in Canada are actually either about informing. It's like, we're just going to tell you what we're going to do about AI. And of course, you're educated, and therefore you're going to trust us because we're more transparent about what we're doing. Some of the traditional methods can be labeled as nothing but therapy, as in let you vent and you'll probably feel better. And then we'll go away and we will do whatever we were going to do in the beginning. Those are non-participation, but there are many forms that are tokenistic. So even public consultation can be relatively tokenistic, where you're getting public feedback and you're perhaps using natural language processing to extract themes. So you're using what's called an unsupervised classification method. If you go to trending topics on Twitter, that is the prime example of unsupervised classification, where the topics, what's a topic, right? A topic is just an n-grams joining a one word to another. That becomes a topic or a concept. And that is bottom-up emergent as opposed to something called supervised classification. But it's when you start to rise to the top is when you start to get more influence on policy. Now, mind you, there's huge debate about the hierarchical nature of ladders such as this. Also, whether people have the resources to rise to the top, whether people are satisfied with a particular rung of the ladder and they don't need to move further. These are all valid critiques. One additional critique that comes out of the FACT community, this is the Fairness, Accountability, and Transparency in AI and ML community, is why are you talking about government at all? That doesn't make any sense. AI is transjurisdictional. Why aren't you going to the firms themselves? So there's also a question of who's on the outside of this, who's governing the process, and whether it should be the private sector who's governing the responsible AI practice, as called, or the AI, the ethical AI, or the beneficent AI. It goes by several names. And you can see the success or lack of success in private sector approaches, for example, with boycotts, or their famous case last year of Google's AI for Good division, or its ethical AI division, actually firing two of the people, one a woman of color and then another woman after that, because they weren't ethical in the way that Google wanted them to be ethical. So there are definitely limits to the private sector approach, particularly when these companies are global and huge and very powerful, although there are obviously challenges when you interact with government at any level of government as well. So next slide. So in case you were interested, this is the model that we currently have for a participation, a ladder of citizen participation vis-a-vis AI, to which I actually add a rung at the very bottom that doesn't exist in RNC, where I say that there are forms of AI that actually are anti-participation or destroy participation. So you can actually use AI to disrupt engagement or intimidate citizens in terms of surveillance, censorship, disinformation, cyber attacks, targeted arrests, you know, for example, the use of bots to create the illusion of public support where there may not be. And that's something that Arnstein couldn't even conceive of, that you'd actually try to use this. I don't know, probably in her time it'd be like bringing thugs to the meeting who would automatically support whatever you do or start beating people up. There are, as we rise up the ladder, we see AI guided participation, where the AI is used as a tool in the participatory process, like, for example, chatbots. There is a now infamous, I've given a couple of talks at the Revenue Agency about AI and civic participation, and they told me of the story of a chatbot they used as the front line for tax-related questions. And I said, they stopped using it after a while. And I said, well, did you think that most of the people who would use this would be the people, I said, I have a chartered accountant, it's my cousin. He does my taxes. But most of the people who would be using this chatbot, they might be allophones, or they might be marginalized people. The people that you would most want to talk to a human being are talking to a chatbot. There are also ways in which these technologies are used to harvest or scrape public opinion rather than talking to individuals, because it's more efficient. Up to things like, one of the things we don't think about in citizen participation is citizens are often used as sources or annotators. So there's a whole literature on what's called ghost work and how we rely, remember I talked about these classification systems where you needed to have this training data? That is usually done by hand, but it does require thousands and thousands of examples. These examples are often done by crowdsourcing platforms with 1 cent to 5 cents per classification. So we've outsourced a lot of this work, but we also may say, well, people have participated because humans are in the loop. So it's an important thing to carefully reflect on what we mean by participation. Up to talking about sentiment and literacy, that we now have emotional AI, or it's otherwise known as affective computing, that can assess whether people are happy or sad, and that can express via facial recognition technology, where you're scanning people's faces and you're saying, these are happy faces or sad faces. Think about that when you go into work with your employer, can assess whether you're happy or sad to be at your desk. Up to the use of sentiment analysis for natural language processing, where we might see whether people are happy or sad about a particular company or particular government policy. I won't go through all of these, but you can see there's a long way to get to the top, if people ever get to the top at all. There are a few instances about actual counter AI in which small groups of people actually build their own. You might be interested to know that there is a guy in Seattle, Washington, in the US, who built a facial recognition technology system to identify police officers who were in protests, who did not, who removed their badges and their body cameras. So there are a few, but there are some examples of this counter programming. A lot of what we see is capacity building, which can be good or bad. It mostly focuses on literacy, digital literacy. What's more complicated when it focuses on computer literacy. And then the question becomes, once again, as I mentioned at the very beginning, how much do you need to know to be able to use these systems? And is using the system, you can keep it there, sorry. Does the using of the system mean coding the system? So now to the, I think I have time. So I wanted to depart from that to talk about a project that we're working on that might appeal to, straight up DH stuff. So this is a project I have called Data Rescue and Archives Weather, or DRAW. And what we're doing at DRAW is we're trying to use optical character recognition for handwritten cursive logbooks of weather observations. And you can imagine this is really hard because most optical character recognition has been done for typewritten text. If it's done for handwritten text, it's done for, and you can go to the next slide there as well. It's done for block writing as opposed to cursive handwriting. It's, as an aside, it's been an interesting challenge for us to write FAQs. So we built an entire system to elicit data, to get people to transcribe data from these logbooks. You can sort of see a logbook in the background. If you go to the next slide, whoops, go to the next slide and I'll have you go with this. So stay there. So that's what these logbooks look like. So just to back up a bit, one of the things that drives us is that these kinds of logbooks, and they exist worldwide, are the most direct confirmation or refutation of anthropogenic climate change. Granted, they are near history, but almost all of the climate data that's used to support anthropogenic climate change is proxy data. It is not direct observations, which is why this is important. And McGill University Archives has one of the most complete records of Canadian weather in the country. It's pretty much 100 years of weather observations. We don't know exactly how many separate observations there are. It's between 4 million and 9 million separate observations in 15 different logbook formats. So these were up to 9 sub-daily observations per day and up to 47 separate possible variables per observation. That's why you have so many of them. And there are other platforms in the world like Old Weather who are collecting weather data, but they collect only precipitation, barometer, aka pressure, and precipitation. And we're aiming to collect all of it, including things like, this is a good day to change your sleigh rails to wheels. Or a bad day for your petticoats. So we're trying to collect all of that and to see if we can make associations between these algorithmically. So if you go back, so this is really cool. This is a very dynamic archives. We found this data on Tuesday, So this is brand new data about one of the originators of this project, Accord, and it's also an interesting challenge to try to decipher what, there's a lot of weather symbols in there, and it's hard to figure out what those are, and it complicates transcription, which is why we had to build our own platform, because it's not just numeric data, it's alphanumeric. It's sometimes mixed alpha and numeric. And it has symbology too. So the forensics to try to find out what these things are, to try to write a system that will accommodate all of these differences has been challenging. We've been doing this for 5 years now. If you look up Draw McGill, our sit-side platform, you'll find it. Feel free to transcribe some data as well, or I should say transcribe some observations, because as we continually mention, it is not data until it is transcribed. It is not because it is not searchable, nor is it indexable until it's transcribed. And this is also, for you librarians out there, it's a really interesting challenge for us too, with archivists, because we have lots of conversations about the granularity of this that we need. So often archivists will talk about metadata for the data set or the book itself or the series of books. And actually we need, or certain kinds of users need, metadata down to the cell level. And what's the challenge in doing that, especially as an archivist or librarian, when you don't have the domain knowledge to do that, and you can't necessarily always anticipate who the end users will be. So some interesting conversations about schema and metadata and descriptions and who should be doing it and how should it be done. So next slide, and then the slide after that. Okay, so optical character recognition has been tried for these kinds of data sets for a very long time, and they have failed. So we're going to try it. We're trying it again by augmenting the OCR with artificial intelligence. So it just gives you some sense of the challenges that we face. One is, this is not going to be news to anybody who's listening, that often the documents, at least the documents themselves, as well as the scanned versions of the documents, are faded. Another challenge is cursive. Remember, I was talking about classification. When you look at the gold standards of classification for text, sources like ImageNet, they just don't handle cursive. So it is surprising how difficult it is for a computer to distinguish between a capital N and a capital W, which of course for wind directions becomes very important. So it's, because they're very curly when you write them out, and people have very beautiful cursive handwriting. And I could go on about finding students who actually can read cursive handwriting, the strange finding that Francophone students are actually better at understanding cursive handwriting than Anglophone students because there's greater exposure to cursive handwriting. So cursive is a huge challenge. As you can see in challenge 3, we have a lot of out of cell values. I suppose people were using crayons at the time, so they were never taught to draw within the lines, but it would be really nice if a computer could say, oh, just detect the bounding boxes or the lines in the ledger sheets and take anything that's within those lines. You can't, because especially with certain numbers like 7s and 1s, they, reach below the line. So if you go to the next slide. So this is the process that we've had to do to even start. applying AI to this process. You would be surprised at how much time we have had to spend on what are called bounding boxes. You probably do not know if you use OCR, for example, to do your taxes and to digitize your receipts, that the first thing it is doing is creating bounding boxes, is drawing little boxes around every number or every set of characters, and then it analyzes it set by set. It doesn't analyze it in its entirety. It has to break it up. So we still are working on, we scan it, we then have to break it into rows. We tried columns, that didn't work. And then from the rows, we have to do 2 bounding boxes of rows, and then we go to bounding boxes of individuals. Then we have to see how well it assesses the value. And then what we didn't think of was how hard it would be to recombine the values into the proper order. So just to give you some sense of the challenges, and with that, I think it's the last slide. Oh, so remember, I got this 2 days ago. Remember when I talked about how much tech is needed in the UI or the user interface? This is documentation for our SQL scripts. And outside of the text mining that's traditionally used in libraries or the other kinds of tools that are used in libraries, to use deep learning at this point largely looks like this. And that's a huge challenge for anyone who's not comfortable. You don't have to be a computer scientist to do this. There are many people who can do SQL, including in library information studies. But it doesn't mean you're time writing user interfaces, especially user interfaces that are durable, which is why so many of the user interfaces that are used in digital humanities are so clunky and require old operating systems, because there's nobody around to revise this stuff. Next slide. So that's basically it. And sorry for the technical problems, but hopefully you have some questions and comments. And remember, ask me anything.
Thank you, Renee.